Alrighty, so today we're going to be looking at, so before we charge off and start looking at algebra and some of the wonderful things you can do and how we operate and rearrange and manipulate algebraic formulas and expressions, it's really, really important to understand some of the hidden conventions. Now, mathematicians are notoriously lazy people. Okay, they love to take a shortcut wherever they can get one. The downside of taking shortcuts and reducing how much writing we have to do is that when you're learning mathematics, it can make it really, really hard to get your head around and identify why you're getting things wrong. So we're going to look at two of the key ones today. There are more, but we're going to look at two of the most common ones, okay, and ones that come up over and over and over again that I see in students' work. Okay, and it's once you're aware of these, it'll make your life a lot easier. So it's really important that you understand what's going on with these two examples of hidden conventions. Then we're going to look at some important information that you need to know to access algebraic expressions and formula effectively. So the first thing we're going to look at is when you've got a number next to a pronumeral. So a pronumeral, just to remind you, is an algebraic term. It can represent an unknown value or a variable, which means it could be any number. When you've got that, when you have nothing written between the two, there is a convention in mathematics that means, and it's only for a number and a pronumeral, that we've got a multiplication there. So that is actually represented as 4 times q. Okay. Hidden convention, one that we see all the time, it comes up over and over and over again. Just be really aware of the fact that when you've got nothing between, no symbol, no operation between a number and a pronumeral, there is a multiplication occurring. Okay? That's the first one. The second one, this is probably more dangerous than the first because it doesn't come up as frequently. So this is one of those ones where every now and then you'll see it, and if you make the mistake, you'll get it wrong, and your teacher may not pick up on it because it only happens every now and then. And that is when we're dealing with terms above and below a fraction line. Now, this doesn't just apply to algebra, but it does come up a fair bit in algebra. You may have an expression like 2 divided by x plus 3. Now, what is actually going on there is that you have, because if we were to do this by BOMDAS, if you were to put that in your calculator, 2 divide x plus 3, what you would get is, let's say x is 2. You get 2 divided by 2, which is 1, plus 3, the answer is 4. When you read that, that's not actually what's going on. Okay? The hidden convention is that we have brackets around both the top and the bottom of a long division line there. So I have a big line, I shouldn't say long division line, but in a big line that separates our numerator and our denominator, if you've got a long line, what that means is that you've got brackets around each of the terms above and below the line. Now, as you can see, the brackets around the 2, they're pretty redundant because we haven't got anything else applying there. However, the brackets around the x plus 3, they're pretty important, and let's look at why that's the case. I want you to pick a number between 1 and 3, just a small number in your head. Okay, it'll be different for everyone. Let x equal that. Now, if you apply the brackets, I'm going to let x equal 1, for example. If I apply the brackets there, I'll get that, and I'll get rid of my writing over here. 2 divided by x plus 3, where x is 1, becomes 2 divided by 4, which we can simplify as 1 over 2. If I didn't have my brackets there, and there are a couple of ways that we see this play out. So I'm going to write in red the incorrect response. Okay. If you were to do something like this, 2 over x plus 2 over 3, what you would get is 2 over 1 plus 2 over 3, sorry, which would give you 2 and 2/3, not the answer we should be getting. I've showed you the way, and this is particularly important, sorry. This is particularly important again, and I'll talk about this in a second. This is particularly important again when we're dealing with order of operations, because as I just showed, we had 2 divided by x plus 3. If I shove that in my calculator without identifying the hidden convention of the brackets around the bottom, so if I get my calculator, it's probably a good idea to do this, just to get this out. If you write in your calculator 2 divided by 1 plus 3, I'll let that equal 1 now. I'm just going to change this to equal 1 so we can see what's going on. If you put that in your calculator, now you know that you should get 1 over 2 or 0.5 as your final answer. If you put that in your calculator, you're going to get 5. If you put brackets around this, BOMDAS will do this first. So the order operations we'll do our 1 plus 3 first, and then go 2 divided by that, which is 1 over 2, or 0.5. So it's really, really important to understand that when we've got these fraction lines as a hidden convention, and to be honest, I don't know why we do it. We really should be putting the brackets around because it doesn't come up that frequently, and it does create a massive amount of confusion. So the final thing I'm going to write here, and it's probably a good idea to write this down in your book somewhere, terms above and below a fraction line need brackets. Super important. Okay, I can't emphasize that enough. You don't want to be making mistakes, not because your mathematical understanding is not right, because you missed a mathematical convention. Before we go any further, I guess it's really important that we look at some of the important information that we need that we've learned that we need to revisit just before we charge off and look at algebra, and specifically rearranging algebra, because that's where we're going to be heading into transposing formulas or manipulating formulas, as it's sometimes called. The first thing you need to understand is the order of operations. Now, it's really important to understand the order of operations as we just saw before, but that is, and you can use BIDMAS, BOMDAS, I don't care what it is. Doesn't really matter as long as you've got brackets, something to do with the power, multiplication and division next to each other, and addition and subtraction next to each other. It really doesn't matter. So BIMDAS is the order of operation, and that tells us how we should go about solving our problems. Really, really important. If we can't follow BIDMAS, we'll get ourselves in trouble. Our calculators follow BIDMAS religiously. So you need to be very, very careful when you're solving these problems to understand not only BIDMAS for you, but when you put something into your calculator, understand that it will follow BIDMAS absolutely relentlessly. So you have to be really careful of those conventions when you're putting stuff into your calculator. The second thing is index laws, okay? I'm not going to list them all, but you need to understand your index laws. It's really, really important to know that x times x equals x squared, or x divided by x equals 1. That comes up over and over and over again. Super important to know. And the last thing I want to address here before we go any further is inverse operations or opposite operations. You can use whichever term you like. If you don't understand what operations cancel each other out, you're going to find algebra really, really tricky. So I'm just going to quickly revisit this, and a lot of us will know this. But if we've got a plus, the opposite operation to a plus is a minus. And that's vice versa, okay? So obviously if you want to undo a subtraction, you have to add, and if you want to undo an addition, you have to subtract. In the same situation, the opposite operation for a multiplication is a divide. And at this stage you probably think I'm just listing Ed Sheeran's latest albums, but that's not the case, because as we're about to find out, and there are more operations we're going to deal with. Let's deal with the squared, okay? So I'm just going to put n squared. How do I undo a squared? That is a tricky one for most of us, and that is a square root. So the same thing applies. If you want to get rid of a square root, you need to square, okay? So you can do square. And we're going to talk about the way that this operates. We'll go one more actually, we'll go one further. This is a tricky one. If I've got sine theta, how do I undo sine theta? And a lot of us just go to the old calculator and shove it in, because that's what the teacher told us to, but the way we undo a sine is we use the inverse sine, or sine -1. Okay. Hope that helps, but these are the three key things, just to revisit: order operations, index laws, and inverse operations. They're the three key pieces of information that you need to know before you start manipulating algebra. And also just to revisit our hidden conventions, little tricks that mathematicians throw into their work. Numbers next to pronumerals means we've got a multiplication, and terms above and below a fraction line need to have brackets, and they won't always do that, but they should have brackets there. Hope that helps.